So in question number 1, if the midpoints PQR of the sides of a triangle are given, then we have to talk about the triangle ABC, whether it is right angle or not. So this can be solved easily just by taking a diagram. So let's take a diagram here, and this is y-axis. Now, since the midpoints PQR are given, let us plot the PQR points. 3, 3 is the first point. Let us take 3, 3 here. Let's take 3, 3 here. And then we have 3, 4, which is here. And then we have a 2, 4, which is here. So these are the 3 points PQR. If I join them, then we will get a triangle like this, which is actually the triangle made by the midpoints of the triangle ABC. This is PQR. So this is 3, 3. This point is 3, 3. And this point is 3, 4. So the distance between them is 1 unit. This is 2, 4. Okay. So this triangle is right angled as well as isosceles. But what about the triangle ABC? Now, since they are the midpoints that I have joined, so the sides of the triangle will be parallel to the side of this, and the length will be double of that. So the triangle, actual triangle side length, one of the side will be like this, parallel to that. Another side will be like this, parallel to that, and twice. And another one will be like this. So this is the actual triangle, which is also equilateral, which is also isosceles and right angled. So that is all. And so therefore the answer of this question is option A. Right. Now let us discuss question number 2 here. It's given that if there is some algebraic relation given here, this is the algebraic relation, which and also another important point that they are talking about family of lines. We know that for family of lines we should be able to express that family as L1 plus lambda L2, then we can find the point of concurrency. But here we can do that. Before that, we have to simplify this relation that is given here. So in this relation, we can see that if I simplify it, we will get 4a whole square plus 5b whole square minus. So 4a minus 5b, 4a minus 5b whole square, and then we will have a minus c square, which is there, is equal to 0. Okay. Upon simplifying this, we will get 4a minus 5b plus c into 4a minus 5b minus c equal to 0. So product of two factor is 0. That means any factor can be 0 here, and therefore we get 4a minus 5b plus c equal to 0. This is 1, and when I compare it with our ax plus by plus c equal to 0, we can get the point of concurrency as 4, minus 5 by comparing these two equations. Right, and if I compare it with the other one, which is 4a minus 5b minus c equal to 0, and the equation is ax plus by plus c equal to 0. This is a family of straight line. If I compare them, we can get the point of concurrency as I have to make it minus c, so minus x and minus y. Minus x is 4, so x is minus 4 and this would be 5. So the points are 4 comma minus 5 or minus 4 comma 5, 4 comma minus 5 or minus 4 comma 5. That is coming in option A. So option A is correct here. That was question number 2. Now in question number 3, the quadratic equation whose roots are the x and y intercepts of the line. So quadratic equation is involved whose roots are given, not given, something about roots are given, that is the x and y intercept of a line. Okay, so let us say the x and y intercept of a line are a and b and they are the roots. So let the roots of quadratic equation be a and b. Okay, then the quadratic equation will be x square minus sum of the root, which is a plus b into x, plus ab equal to 0. Let us now we have to find a plus b and ab. So also a and b are the x and y intercept of the line, and the equation of the line then will become x by a plus y by b equal to 1. Since it passes through 1 comma 1, it will imply 1 by a plus 1 by b equal to 1, which implies a plus b equal to ab. Right, this is one relation we have got. Now it is also given the area made by the triangle. The area of the triangle made by this line with the axis is capital A. So which is capital A, therefore we can say that capital A is equal to half into AB, which implies AB equal to 2A. Also from equation A, from equation 1, we can say A plus B is also 2A. Therefore our quadratic equation will become x square minus 2a, x square minus 2ax plus 2a. That is option B. So this was pretty easy. Now let us consider question number 4. Here one diagonal of a square of the portion of the line this intercepted between the coordinate axis. Right. So one of the diagonal is given, that is the main point here. One of the diagonal is given and the portion of the diagonal is intercepted between the axis. Okay, let's draw a diagram, maybe that will help us. Let's take the axis. Let us say this is x-axis and this is y-axis. Right, now there is a line x by a plus y by b equal to 1. We have to draw that line. Let's draw that line first. Let us say a is greater than b, so it will be like this. This is the line, something like this. Right, so this is the line x by a plus y by b equal to 1. Now this portion between the axis, say a and b, is the portion between the axis is one of the diagonal of the square. So if this is one of the diagonal, what is the other diagonal? The other diagonal will be perpendicular to this, and the other diagonal will be perpendicular to this and also of same length. So maybe it will be something like this. Something like this. Now I have to draw, get the square and let the square be like this, this joint, and then we get this one, and then this one. This looks like a square almost. So this is our diagram. So now what we have to find? Oh, this side equation is given. Equation of this side is x by a plus y by b equal to 1. This side x by a plus y by b equal to 1. Right. What we have to find is we have to find the extremities of the other diagonal. So let us say this is capital A and this is capital B. These two can be easily understood as this is a comma 0 because the equation is given, and this is 0 comma b. So these two can be easily found, and this point is a by 2 comma b by 2, a by 2 comma b by 2. It is the midpoint of the diagram, and this is 90 degree. Now here we can solve it by coordinate geometry concept, or we can solve it by complex number. Let us solve it by complex number. Let us take this point C and this point D. Let us say take the point C as Z1. This is Z2 in terms of complex number. So point capital A is A plus 0i, and point D, say this midpoint is D. This is A by 2 plus B by 2i in terms of complex number. So if I use the concept of rotation, it will be like this. We can write that Z1 CD vector equal to AD vector, not CD, we can take a DC vector equal to dA vector into e to the power I pi by 2. E to the power I pi by 2 is I. So from here we can write that DC vector is nothing but Z1 minus A plus BI by 2 equal to dA vector is A minus A by 2, that's A by 2, plus 0 minus B by 2, minus BI by 2 into I. Right, so therefore our Z1, this one is becoming A1 by A by 2I and B by 2. So B plus AI, B plus AI divided by 2. After simplification, it is B plus AI divided by 2. So therefore our Z1, this implies our Z1 is equal to B plus AI by 2 and then plus A plus BI by 2. So when I add them, I get A plus B by 2. That's A plus B by 2 is the real part, plus I times another A plus B by 2. That is the imaginary part. So this is for the point C. Similarly, we can find D also, and if you find that, you will get, since here we are saying in option D we have that A plus B by 2, A plus B by 2, no other option is like that. So that is the correct one. Second point you can find that will become A minus B by 2 comma B minus A by 2, similarly by taking rotation by an angle pi by 2 clockwise.